All right, welcome everyone to Birmingham Elixir. People have been saying it's like the Austin city limits of remote Elixir meetups. Oh gosh, I skipped too far ahead. Today we have Marlus. He's going to talk to us about Surface UI. Marlus is a software engineer at DashBit. I think that's still accurate. Marlus, feel free to correct me if it's not.
That's correct.
Okay. I think I skipped a slide or two, but you're the guest of honor, so I'll just let you kick it off from here.
Okay, so let me try to share my screen. Is it working?
Yeah, looks good.
Okay, perfect. So yeah, thanks for inviting me to the meetup. This presentation is going to basically be some. I'm going to try to detail, give you more information about the blog post I wrote about a couple of months ago, where we try to summarize the efforts to bring a better component model to Liveview. So there were a lot of questions that were raised after the blog post, and I think it would be a nice opportunity to answer some of those questions. So in case anyone hasn't read this blog post, it's available on DashBit website, and I think you should take a look at it if you intend to use Liveview or Surface, because it details, it gives some information about the current efforts on that front. So I'm not sure. Probably there might be people that hasn't been using Surface or even Liveview. So I'll try to be very short on some introduction about the motivation and why I created Surface in the first place. So the idea, I mean, the motivation behind Surface was actually in 2019, when I had a presentation, I have a talk at ElixirConf, and the presentation was about building efficient pipelines in Broadway. So what I wanted to demonstrate was I wanted to have a live dashboard where I could show the topology of the pipeline that was processing data with Broadway. And I really want to have a very live dashboard with real-time information about the topology, so where you could see the stages and the process, and which process were actually maybe being a bottleneck for the pipeline. So it was a real nice way to visualize the pipeline. So the Liveview was extremely new back then. So I decided to give it a try, and it turns out to be a perfect choice to this kind of applications. I mean, I was really amazed how everything went so well with Liveview when it comes to what I wanted to achieve. And my first impression, as I said, was, I mean, Liveview is fantastic. I really want to use this. I want to have this on my stack. Having the logic, the business logic on the server close to your data, it's absolutely fantastic. It really boosts productivity. So this was probably the main thing that captured my attention. And as I said, I mean, the productivity was really much higher than I ever tried in anything on the web. To create web applications. However, this experience with this dashboard, the first version I created only with Liveview, and although we had the live component thing to create components, I think we were still missing a lot of stuff to get to be considered a real component model. So basically what I felt was missing in Liveview was first the stateless API was very limited. Actually, there was not a stateless API. It was like the stateful API, but you could use it as a stateless component, but there was a series of limitations. So another problem was that the template, the leaks template engine was not aware of the structure of the HTML. And the third gap I think we had there was the lack of a declarative interface for components. So there was no way to define the public interface of a component. So the first gap, right, that I was talking about, which is the limited stateless component API, is that we couldn't reuse stateless components in controller-based views or layouts, right? That was something that was missing, and so because of this problem, people start to move some of the code in the template from the component to pure functions. So you could define something that would look like a stateless components, right? In pure functions, you bring the piece of the template to the function. But the problem is that when you do that, then you lose composability, right? I mean, if you had a component using live component, even if it's stateless, it would compose well with stateful components. So you could actually have a stateless component, define some kind of markup, and then you could include stateful components. But from the moment you had that stateless components in pure functions, you couldn't do that anymore. So it was something that was really critical, in my opinion, for a good component model. If you ever try to do that, you'll get that nice message telling that you can only, a component can only be returned directly from part of the Liveview template if you ever try to use a stateful component inside a stateless component that was in a pure function. So the second gap, which was the template engine, is the EX it's great. I mean, it's really fast and it's amazing what you can do. The performance is completely it's amazing, but the biggest problem is that it makes no distinction from plain text and a structured format like HTML. So all that information, right, that is present in that file, in that template, the structured information of the HTML and the components, the template, the engine has no information about the semantic. It doesn't care about the semantics. So this is critical because there's so much important information there that you can use to make some really nice things, right? Even if you can't use that information to bring all those amazing things, some basic things couldn't be done, which is just validate the template. So for Liveview, this was extremely critical because if you ever forget, if you ever used stateful components with events and you have you forgot to close a div, for instance, the browser will try to close that div somewhere, and you're actually going to have a structure that cannot be mapped in the server because that's what Liveview does. It maps the state of each component, stateful component, right, on the server. So it really requires that the structure is it's correct. So if you forget to close a div, you try to close somewhere else, and from the moment you start to interact with events and stuff, and Liveview start to update the view, you could see completely crazy behaviors, updating stuff that shouldn't update and all. So this was really important. So the third gap was the lack of declarative interface. So we always consider components as building blocks, right? So you have building blocks that you can compose together to create another build blocks. So you need to know the shape of those blocks if you want to compose them. And in plain Liveview, I really missed this a lot because whenever I need to use a component made by somebody else, and I want to see what the component does. I mean, what's the public interface? How can I interact with this component? I always had to look at the template, maybe trying to visualize the assigns that are used. And I think it brings to a very a bad experience for the developer when it try to use a component, it doesn't know the shape of the component, it doesn't know how to interact. So without this declarative interface, right? I mean, that's why I was always going to the template and try to identify how the component was behaving, because I need to answer those questions, right? If you don't have a declarative interface for the component, you need to know which assigns are public, right? And you can pass those assigns to the live component. So you need to know the types of that information, because you need to pass those assigns, because you can define a size internally that you're going to use in your stateful component, but there are some assigns that you're going to pass as arguments in the function call, in the live component function call. So you need to know the types. You need to know if any of those assigns are required, because maybe some of them are critical to the component. So you need to know if they're required or not. You also need to know, okay, if I don't pass it, maybe it's optional, but if it's optional and if I don't pass it, what's going to be the default value of this? How the component will behave if I don't pass this information? You need to know, you need to answer, you need to answer the question of which assigns are public and which assigns are private. I mean, if I take a look at the template, I'm just going to see assigns everywhere, and I can say, oh, there's a assign here that changed this, so I'm going to pass it as an argument to the live component. But maybe you shouldn't do that, because maybe that assign was meant to be internal, to represent the internal state of the component instead of some kind of property or attributes that you pass to it. So having those gaps, I just thought, okay, Liveview is great. So how can you improve it, right? I mean, can we fill those gaps? And that's how Surface emerged. So I tried to with the idea of creating the dashboard, I say, okay, how can I do this? How can I create maybe a template engine that could understand the structure of the template, so I can actually inject components? Can I have a declarative interface? So that was the first thing that Surface did, was the first thing that I tried to do to create that dashboard. So the first thing was about the template engine. So to create a new template engine, I need to define a new language for the template. And since I had some experience already with React, I thought it would be a good idea to bring that model, which was, in my opinion, a very successful model, at least from the point of view of the template, but not only React. I mean, we brought a lot of ideas from Vue.js as well and Svelte. So it's not the template engine was never meant to be compatible with any of that stuff, especially because you have a different scenario. You need to take into account the server nature of Liveview. So some of the things that apply to React and all of those JS frameworks, they just don't apply to Liveview. So as you can see, the template language is pretty simple. You define components the same way you define HTML tags. So another thing that you brought to the engine is, okay, since we have the information about the structure and you have the declarative API that can define the public interface of the component, we can cross this information and provide static checking. So we can have static validation not only in the structure, right, but we can have in the semantic field. So we know the semantics, we know the information that the object needs, and we know what's in the template. So you can cross this information. So here's an example of the declarative interface, right? You can define properties, which means properties are information that it's passed to the component from the user perspective, right? So it's public information that you need to pass to the component. You can define slots, which is similar to properties, as they are information that the user of the component pass, but instead of passing information as structured data, you pass it as template blocks as those slots. So you can also have a clear separation of what's public and what is private. Even though you don't, to use a component, you don't need to know about the internal state. From the perspective of the one that is creating the component and maintaining the component, it is important information to know the internal state, because you can still, we can still use that declarative approach to define default values for that data and other stuff. You can also have more static information. If you know if something it's meant to be private and something tries to use it as public, you can raise an error at compile time and say, look, this is not public information. You can't pass this information directly. So the benefits, as I said, it's static validation. You can have static validation. The first example we had was just a typo in the ending tags, right? In the closing tag. So this is just about the structure, but there's no semantic in that validation. So here we have an example of a static validation of something that has based on the semantics of the component. So you're trying there's no property defined, right, as class with Z. So you know that because you have declared that, and we know that because you're trying to, you have the template that gives you that information. So you can also generate documentation. So this is a big problem when you use a component, and if the author of the component doesn't do a good job documenting the component, it's really hard to know how the component is going to behave. So since you already have a declarative approach, you at least know exactly how to use the component and how it should interact with other components, because you have that information. You can generate documentation automatically. You can also provide better toolings. The Surface Catalog is our attempt to have something like a storybook for Liveview. And basically, you don't have to have a real application to test a component. So you can have, with the catalog, you can use your component and you can interact just providing the public information of the component. You can change the properties of the component and you can see how the component behave. So this is only possible if you have that declarative approach, the declarative language, where you can define the API of the component, the public interface of the component. There are many other stuff that you can do when you follow that model, right? That more strict model. So you can have very precise formatters. If you haven't been following the Elixir forum, you know that the formatting EX templates has been historically a pain, because since it doesn't recognize the structure, you can actually, it will accept anything, but the formatter needs to know the minimum of the structure to format it precisely. You can also provide autocomplete and suggestion for editors. The information is there. You can introspect the information of each component to see what properties or slots or events are available. We can also create converters. This was something that really surprised me, because we released the new 0.5 version with a new syntax. There was a lot of change in the syntax from 0.4, and that was something that I was concerned, because it's hard. I mean, if we invest already time and money building something, and then you change the syntax, I think we should provide a way to minimize the pain when you want to migrate the application to the next version. So we decided to have a converter, a built-in converter. When you update Surface, you already have a task, which is mix surface convert, and then we automatically change all the syntax you had in the previous version to the new one. And the feedback was amazing about this feature, because I was surprised. I was thinking people maybe wouldn't care much and we'll just try to replace, but the feedback was amazing because you could just update, run the converter, and you're there. So no warnings, nothing. It was so this is only possible because you know the structure, right, of the template and all that stuff. And we decided even to keep this converter, we created a small API that will allow to, in each version we release, you have a compromise to, if something is possible to be automatically converted to the new syntax, if you change something in that regard, we're going to provide the rules to the converter so it can be automatically migrated. And there's many more stuff that we can do with this model. So we have that in Surface for some time already, but the third gap that I was mentioning, which is the stateless component API, there was not much we could do about it, because even we tried to do this. The way we tried to do this, we create two separate abstractions, one for stateful components and another one for stateless. But they still, in order to compose, they be composable, we needed to both needed to use the live component macro, right? So it's still an incomplete API. We couldn't use those components in controller based views. So for this kind of problem, there's only one solution, which is to bring the concept to Liveview itself. So the first PR we did in that direction was the one that brought the new macro that could replace live component, but for a stateless component. So that's the way we found to contribute back to Liveview, because we had so great things from Liveview, and then we found that maybe it's time to bring back something from the experience you have in this past 2 years with Surface. Maybe it's time to talk to them and see how we can bring some of those concepts. So the first one was this, and this solves the problem of the stateless component. So if you try Liveview, I think from version 1.15.6, I think, or 7, you already have that function there. So you can now define components as pure functions, and you can use a similar interface, and you can inject live components in those function components now. You can also use those components in layouts or controller-based views. So this was the last missing gap we had regarding the component model. So in Surface, you already have, we already changed the implementation of the stateless component to use this new component. So if you try out Surface, the version of master, you can already define your stateless components and use them in that views. So what about Higgs? The other PR we contributed was a new templating language that could replace the leaks, which was purely based on EX. So the thing, Higgs, it's basically what we wanted regarding having a template engine that could recognize the information of the structure of the template, but trying to keep as compatible as possible with EX. So that would be basically the difference. I mean, the main difference between Surface and Higgs is that Higgs tries to keep compatibility with EX, and Surface doesn't. And here's an example of the new Higgs language. It's very similar to Surface. If you take the parts of the attributes of the component and the HTML tags, they're pretty much the same. The difference is going to be basically on the body of the tags or the components. So they still use the same way to interpolate and to inject expressions as in EX. And in Surface, it's the same way. The same way you inject expressions in attribute values, you inject information in the body, just like React. So regarding Liveview and consequently Surface, the path to our component model, to complete our component model, has already begun. I mean, you already have the template engine, and this is important for Surface as well, because, I mean, how can you have a model that we can build Surface on top of it if that model doesn't have a way to prove that model? Right? We need to have a template, a building template language, so you can validate those new concepts that we're bringing to Liveview. So Higgs already has support for stateless components. There is no syntax yet defined for stateful components. So if you want to use stateful components, you still need to use the live component macro directly in the template using the X interpolation, the same way you use in EX, in Leaks. Stateless components are already working with component, and the declarative interface, it's not defined yet for Higgs, but it will eventually be there. I mean, there's a lot of stuff we still need to do on the Liveview side, a lot of concepts to bring, but the declarative interface, it's one of the priorities. I think there are two priorities. The first one is slots, which is a concept we have in Surface and we don't have in Liveview. And it's a very important concept. Chris has already decided he has to bring that concept too, and it will make our life much easier. Every concept we bring from Surface to Liveview, it makes our life in Surface much easier. We have much less code to maintain, and we can focus on high level features. So the goal of this combined effort between the Surface team and the Liveview team is to establish Phoenix as a great foundation for writing components. And I think the two biggest steps in that direction we took already, and the last one will be maybe the declarative approach. So for the three gaps we had, we already addressed two of them, which is and probably the most important ones, more complicated to handle inside Liveview. And the end goal is that you can see, once you have that model in Liveview, you can create components, you can build components on top of that same model in any template language. You can have components written in Higgs that you can use in Surface, and you can have components written in Surface that you can use in Higgs without any additional cost. So that would be the goal, and I think that would be something really nice, because that's not something you can see even in other front-end solutions. Usually if you develop a component in React, it won't work in React, and not going to work in Vue.js. Same way, if you develop something on Svelte, it's not going to work properly on other, or at least not without a couple of hacks. So I think the model, if you manage to bring all those concepts that you have in Surface to Liveview, to the core of the Liveview, this will bring a lot of possibilities, because it doesn't matter what the template language is going to be a matter of preference to the user, to the developer. So I think it's a very powerful approach. So still on that template idea. So since you're gonna have Higgs, why having another template language, right? Like Surface or any other one. The one problem, it's hard to say problem, but because it's not actually a problem, it has benefits, right? I mean, if you keep compatibility with EX, it's not a problem in the sense that you can reuse stuff that you already did. But I think the way that we have the way that Higgs is like any EX template variant, it's that you need to embed Elixir in the template language, right? So it's not Elixir, but you can inject pieces of Elixir code to generate like a third language. And I think with this approach, we kind of lose the ability to have some more tailor-made language just for templates, because it's a completely different domain. I think Elixir is a great language to write business rules on a server. I'm not sure if it's the perfect language for templates. I think if you have a more specific language for template, you might achieve a better readability and maybe usability from the developer perspective. I think you can create a simpler language. I mean, you don't need all things you have in Elixir in the template side on the view, because usually the view, if you start to put in too much logic in the view, you probably do already something wrong, right? I mean, most of the complicated logic should be done somewhere else in Elixir, and you just have maybe to compose the assigns that you need to use in the view. So for the view, you basically just need some conditionals, a way to traverse data structures, and that's it. So I think you can achieve better ergonomics if you have a separated language. You may also have better static checking. And you can also avoid some common pitfalls, because one problem when you embed Elixir in EX, it's that you have a limited version of Elixir. There's a lot of stuff that you usually do in Elixir that you cannot do in the template in EX. The use of pipes are limited, right? The use of anonymous function is also limited. Defining variables, there's a lot of things that you cannot do on a template, because Higgs, you have partial expressions, right? I mean, you can start an expression and then we embed the template code, and then you have another piece of the expression, another piece of template, and then you have maybe ending the expression. So the expression is only complete after the engine evaluates all that stuff. So at the end, maybe you're going to do something that you cannot use. So if you want to go through a list to print to render each item of the list, you should use for, but you cannot use map, because you cannot pass anonymous function and have the template inside that function component. It's not going to work. So you already have a bunch of limitations when you bring Elixir. So I think instead of knowing all the pitfalls you have when you do that, maybe it's better to just have a simpler language on the template side. So here's one example, what I'm saying for, it's very common when you have a list and you want to render the items, it's very common to render something else if the list is empty. So we used to do this a lot in templates, right? I mean, you just want to render all items, and if there's no items, you just say, render another, something else. So with this tailor-made language for templates, we can actually use, okay, we do this a lot in our template, so why don't we just have a for else? We could have a for else because it makes sense for for templates, it doesn't makes much sense for Elixir itself, because usually you use for comprehensions to traverse lists and usually to map lists or reduce lists. So it's expected if you have input in a for comprehension and the output is an empty list, it just goes it just goes forward in a pipeline without a problem. But the template, it's like the end of the pipeline. If you have an empty list and you're showing something that empty list, you're probably gonna to print something else if the list is empty. So with this separate language, you can do that kind of stuff that I don't know if you can do, and if you should actually do in Elixir. I don't think we should have the else in Elixir, but I think it makes sense on a template. This is another example. Why have if else, if you already have Const? One of the things that I think we can do with different template language is to be more friendly to users outside the Elixir community. So I'm pretty sure the Const is very familiar to all of us, but for people coming from other languages, I think if else is something that I'm sure everyone will know how to work. So why not use it since you already have this smaller language? There are a bunch of other stuff that introduce in the new syntax. So a lot of shorthand notations. So to define slots, it's much more compact the way you can define slots right now. We also had the concept of tagged expressions. So this is a common thing you do in the template. So you create assigns that's going to be assigned to an attribute with the same name. So with tagged expressions, we can do this. We can add syntactic sugar for those kind of things. The same way with dynamic attributes, we can use something that will look like the spread operator in JavaScript. So it's really familiar for people coming from all the other solutions. And this is basic what I had to say about I think that was the main thing that I need to have more detail regarding the blog post. So it's about the future of Surface and Liveview. So as I said, I mean, everything we are bringing to Liveview is to make the model much more friendly, much more powerful, the component model. And I think this model will go until we get to the template languages. So at the end, what I want is to Surface to be only this much thinner layer on top of Liveview, and all those concept slots, contexts, all the things that you can do regarding the declarative approach, they should be all there in Liveview. And then if you like that model and you prefer to use Surface as a template language, we will be able to do it. If you want to stick with the EX-like syntax, you can do it. Or even if somebody else wants to bring a third template solution, it will be possible. So I think that's what we are heading for. That's what our goal is. And I hope we can get that pretty soon. I mean, we've done a lot already this year in that regard, and we'll keep moving on that direction.
That was great, Marlus. Thank you very much.